Alright, so let's take a peek here. I'm going to go through the answers and how to solve each of these problems as a review for the many calculations we have to do for this next exam. So, number one, assume there are only two goods in the economy. So this economy only produces French fries and onion rings. In 2009, they produce 1 million servings of French fries at 40 cents each, and then 800,000 servings of onion rings at 60 cents each. So the nominal GDP in 2009 is simply the value of what is produced times that year's prices. So the million servings of French fries at 40 cents each is 1 million times 40 cents, which gives us $400,000 worth of French fries. We're going to add to that how many onion rings were produced at 60 cents each. So 800,000 times 60 cents is 480,000. So when we add those together, we get 880,000, and that is our nominal GDP for 2009. Alright, so now we'll do it for 2010. Now 2010, the numbers are a little bit more difficult for me to do in my head, so I'm going to write out all the work so that we're clear on everything. So in 2010, the economy produced 900,000 French fries at a price of 50 cents each. So 900,000 times 50 cents is $450,000 worth of French fries. Now we're going to add to that the amount of onion rings. So I'm going to take $1 million, or no, not $1 million, I'm sorry, 840,000 onion rings, 840,000, and I'm going to multiply that by 69 cents. And I get 579,600. That's how much in onion rings were produced. So when I add that to the French fries that were produced that year, we get $1,029,600 worth of output. Alright, so that's the nominal GDP for each year. All we do is we multiply the price times the output to get that. Now for real GDP, we are going to use these two deflators up at the top, the price index. Alright, so in 2009 the price index was 100. So to calculate real GDP in 2009, we just take 880,000, which was the nominal GDP, and we're going to divide that by the price index of 100. Then we multiply by 100 to get real GDP, and it is $880,000. Now notice the real GDP in those 2 years are the same. I mean, the nominal and the real GDP that year is the same, and that's because in the base year, nominal and real GDP are the same. Now, how did I know that was the base year? Because the price index is 100. Anytime the price index is 100, that'll be your base year. Alright, so let's keep going. Real GDP in 2010. Now we're going to take the $1,029,600 worth of output, and we're going to divide by the deflator that year, which is 120, and then multiply by 100. And so, pull out my trusty calculator. 1,029,600 divided by 120 times 100 gives me $858,000 worth of output. Now if you look at the 2 years and compare them, we see that the output has decreased. So we are in a recession. Alright? So that's how you answer A through D. Now, E is simply what's the inflation rate. Well, to calculate the inflation rate, let me show you the formula for that. Here you go, inflation rate. Alright, there's a bunch of ways to do it, but they're all the same, just using different variables. So you can use the market basket, you can use the price index. Okay, those are all ways to do it. And so really all we're going to do is we're going to take the change in the market basket or the price index and then divide by the original market basket or price index. In this case we were given the price index. So the original price index was 100. The new one is 120. So if we find the difference between them, we get 20. So then we take that change of 20 and we divide by the original amount of 100, multiply by 100, and we get inflation of 20%. So that's how we do that. So we are finished with number 1. Okay. Number 2. Now we're looking at an economy that produces 3 goods. Okay, the 3 goods are computers, DVDs, and pizza. The table below shows the output and the prices of the 3 goods for the years 2015, 16, and 17. So A is simply a percent change problem. So it's not really an economics question, it's more of a, hey, by what percentage did the computer production change by? Well, they had 10 computers in 2015, now they have 10 and a half in 2016. So you just take, this is how you do it, you take the change in production and you divide by the original amount and then multiply by 100. So in this case the change is 0.5, the original number of computers is 10, you multiply by 100 and you get 5%. So the output changed by 5%. Alright, B is very similar, except now the variable is prices. So we're calculating the percent change in the price of pizza. So again, you take the change, divide by the original, and then multiply by 100. So pizza prices went from $16 to $17. So the difference there is 1. So the change was 1. If we divide that by the original price of 16 and then multiply by 100, we get 6.25%. So that's the percent change in the price of pizza. Alright, C. Calculate nominal GDP for Lynchburg for 2015. So nominal GDP, we do exactly how we did in the first problem. We're just going to take the price of the output and multiply it by the output and then add that up for each good that is produced. So for 2015 they made 10 computers at $900 each. Okay, and then we're going to add that to the 100 DVDs times $10 each, and we're going to add that to the 2 pizzas at $15 each. And when we add all that up we get 9,000 worth of computers plus $1,000 worth of DVDs plus $30 worth of pizza, and so that adds up to $10,030. So that's the nominal GDP for 2015. Now remember, for part D, remember in the base year the price index is 100. Another neat thing about the base year is that the real GDP will be equal to the nominal GDP. And here's why. So when we calculate real GDP, we're going to take the, well, let me show you the formula real quick so you can see where it is on this. So real GDP right here. We take the nominal GDP divided by a price index and then multiply by 100. So let's go do that. Divided by 100 times 100 equals 10,030. Now for part D we knew what the price index was. It's 100. And so that's why we were able to use that formula. If you look at part E, it's asking us to calculate real GDP for 2017, but we don't have a price index for that. So doing it using that method is not going to be possible. Okay, so there's actually 2 ways to calculate real GDP. So we just used the first one. The second one here is what we're going to use for part E. We're just going to take the base year pricing and multiply it by the current year's output. So if we go back to our problem, the current year output for computers is 12, and we multiply that by the base year price. So let me see, what is 900 times 12? It is 10,800, so we're going to add that to the $10 DVD times the new output of 110. So 10 times 110 is 1,100. And then we're going to add a $15 pizza times the new output of $3. And that's going to be $45. So if we add all of that up, we get $11,945 in real GDP for year 2017. Okay, so that's some little tricks. We used several formulas here. Okay, we used the nominal GDP formula, we used real GDP both ways on that problem, and I believe we used these rate of change formulas. Okay, we didn't call it an inflation rate or a real GDP growth rate, but that's how we calculated the change in pizza production and the change in price of pizzas. Alright, so let's roll to the next problem. Okay, number 3, we've already discussed this, but I'll lay out a few reasons why GDP doesn't capture our total standard of living. Okay, GDP does not include leisure time. GDP does not include our health, okay, or life expectancy. GDP does not include environmental impact. Okay, so the point is that we could have the highest GDP in the world, but if we work 90 hours a week, we have no leisure time. If we have tons of pollution and we're working ourselves to death, our health is bad. Environmental effects of production could be more pollution and things like that. So GDP doesn't capture those things, but it's still probably the best single measure we have to measure our standard of living. Alright, number 4. So number 4, we're going to calculate a price index for 2014, 15, and 16 using 2015 as the base year. Now, before we do that, let's review those formulas. Let me get rid of some of this clutter. Alright, so a price index. To get a price index, we have to find a market basket price. Alright, so we have current price of a market basket divided by the base year price of a market basket times 100. In order to get the market basket, look at number 5 here. That's how we're going to do it. We're going to take the price of item 1 times the quantity of item 1 plus the price of item 2 times the quantity of item 2. So when we come back to our chart, the market basket contains 2 Dr. Peppers, 2 Whataburgers, 4 Reese's, 2 movie tickets, and 10 gallons of gas. Alright, so in 2014, those 2 Dr. Peppers are $1 a piece, so $2 worth of Dr. Pepper go into the market basket. Then we've got $6 worth of Whataburger, and then 4 times 60 cents gives us $2.40 worth of Reese's, and then we got $18 worth of movie tickets, and finally $30 worth of gas. So the market basket adds up this year to $58.40. Okay. For 2015, we do the same thing. Market basket for Dr. Pepper is $2.50. Then we're going to add $7 worth of Whataburger. We're going to add $3 worth of Reese's, $20 worth of movie tickets, and $27.50 worth of gasoline. So $47.50, $50.50, $57.50, total is $60. So that's the market basket for 2015. For 2016, we're going to do the same thing. You have $3 worth of Dr. Pepper, $7.50 worth of Whataburger. You've got $4 worth of Reese's, and then $24 worth of movies, and then $26.50 for our gasoline. So when we add that up, we get $10.50, $14.50, $38.50, $58, $54, $55, $65 worth of the market basket. Alright, so then let's go back and review what we got to do next. So we just calculated the market basket for each of those years. Now we're going to use the price index equation to calculate the price index. So we're going to take the current price of the market basket, divide by the base year price of the market basket. So let's go back. The current market basket for 2014 would be the $58.40 for 2014. The base year is 2015. So for 2015, the market basket is $60. So when we divide $58.40 by 60, let's see what we get. We get a price index for 2014 of 97.33. Alright, Let's do the same thing for 2015. Now the current market basket is $60 because 2015 is now our current year. 2015 is also our base year. And then we multiply by 100 and we get 100. So in the base year the price index is always 100 because the market basket divided by itself times 100 is 100. Alright, in 2016 we've got $65 divided by 60 times 100 gives us 108.33. And that's how we calculate price indices. Now, we can use the price index or the market basket to calculate the inflation rate. So let's go back and review that formula. So inflation rate is number 6 here. You can take price index number 2, subtract price index number 1, divide by price index number 1, and then multiply by 100. Alright, that's one way. Or you can take the market basket and then subtract the first market basket and then divide by the first market basket times 100. Or you can rewrite those two equations as simply the change in the market basket or price index divided by the original market basket or price index. Alright, so we can do it all of those ways. It makes no difference, okay, because we will get the same number. So for 2015, in other words, the inflation from 2014 to 2015, you can take the price index of 100 for 2015, subtract the previous one, and then divide by the previous price index. Multiply by 100, and you get an inflation rate of, let's see what it is. I got 2.74%. So prices increased that year by 2.74%. Alright, if you do the same thing with the market baskets, you get the exact same answer. You could take 60, subtract the previous market basket, and then divide by the previous market basket, multiply by 100, and you get the exact same answer. Alright, so part B, we're going to use those price indexes to determine what real GDP is in each of those years. So again, let's go back and look at that formula. Real GDP is just nominal GDP divided by the price index times 100. So let's do that. So we're going to take for 2014, we're going to take the nominal GDP of 10,000 and we're going to divide by the index that year of 97.33 and then multiply by 100. So let's see what we get. 10,000 divided by 97.33, we get $10,274.32. That would be our real GDP. Okay, for 2015, our real GDP is just 11,000. Because remember, nominal and real are going to be the same number in the base year. And we were told previously that the base year was 2015. Alright, then 2016, we're going to take 12,000. And we're going to divide by its deflator of 108.33. And then multiply by 100. Did you notice I called it a deflator that time? So make sure you're aware that an index and a deflator are the same thing. All they do is, there's just different words for the same number. Alright. So real GDP in 2016 is 11,077.26 cents. Alright, now let's look at economic growth rates. So we have a formula for that. So let's see, here it is, number 7. Economic growth rates are just the growth rate for real GDP. So all you do is you take the change in GDP and you divide by the original GDP and then multiply by 100. So if we're doing 2 years, you take real GDP number 2, subtract real GDP number 1, divide by real GDP number 1, multiply by 100. So for our purposes here, whoops, back and forth. Alright, the economic growth rate for each year. For 2015, we're going to take the GDP for 2015 and we're going to subtract the real GDP for 2014. Then we're going to divide by the GDP from 2014 and multiply by 100. That'll give us our economic growth rate. So when I do that, I don't have a real calculator, I'm using my phone. 32 equals, I got 7.06%. Okay, so that's how much GDP grew by that year. Alright, that's kind of interesting. Then in 2016, we take the change in real GDP. Now this one's a little easier because it just went from 11,000 to 11,077.26. So I'm just going to skip to the change, which was 77.26. And then I'm going to divide by that original GDP amount of 11,000. And then multiply by 100. So for that one, we get 77.26 divided by 11,000 times 100 is 0.70%. Okay? So that's how we calculate the GDP growth rates. Unemployment. Alright. So when we talk about being unemployed, that means you are jobless, but part two, you're actively looking. You're actively seeking a job. Okay? So you just being jobless doesn't cut it. You have to be jobless and looking for a job to be considered unemployed. So we have three types of unemployment. You can read about them here. They're pretty straightforward. We've already discussed them. So what I'm going to do is just throw the answers out here. If I leave my job to become a stay-at-home mom, guess what? I am not unemployed. I'm not part of the labor force in that situation because I'm not looking for a job. Alright? What about when Sam is laid off when the economy experiences a recession? Well, Sam would be unemployed and it would be cyclical unemployment. Okay, because the economy caused it, the recession. Jason drops out of his GED program. That's going to be structural unemployment. And the reason is because his skills. Okay, he has a lack of skills because of his education. Alright. Michael the human calculator is replaced by the TI-83. That would also be structural. Okay, because a machine replaced him. Okay, again, his skills are not in demand because a machine can do what he can do. Alright. I leave my job as a teacher to look for work in the fast food industry. That'd be frictional unemployment. So when you leave one job and search for another job, it's frictional. Greg graduates from college and begins looking for work. That would also be frictional. Okay, because we presume that through his education he has skills that are in demand. He's just looking for the right job at this point. Gage likes to sleep on the couch all day and at night play Call of Duty. He has difficulty finding a girlfriend and a job, and he's given up both pursuits. So if somebody's given up looking for work, they're no longer considered unemployed. They're not in the labor force. And we would probably call them a discouraged worker. Alright, Michael cannot find work in the typewriter repair industry. This would also be structural because consumer tastes have made his job obsolete. Nobody wants a typewriter anymore. So his skills are not in demand. Barack Obama leaves the White House and retires. He's not unemployed. He's not in the labor force. Okay. People stop buying new cars because of the downturn in the economy. Auto workers are laid off. That is going to be cyclical because the business cycle has caused the unemployment. And then lastly, Ditch Witch automated trenching tools replace human ditch diggers. That also is structural because a machine replaced a human. Alright, so when we calculate unemployment, first you have to know who is considered unemployed, and that's why we just went through that exercise. But to calculate it, you take the number of people that are unemployed and you divide by the number of people in the labor force, and then multiply by 100. Special note, the labor force is the number of people employed plus the number of people unemployed. Notice I didn't say the number of people that are jobless. It's the number of people that are unemployed. So, in the city of Plano, there's 245,765 employed in full-time jobs, 8,567 without work and looking for jobs. 3456 discouraged workers. These discouraged workers don't count in our statistics, so we're not going to include them. But we do have 245,765 employed, and then we have unemployed numbers of 8567. Those added together give us our labor force, which, when I add that up, 245,765 plus 8567, I get 254,332. So to calculate unemployment, we just take the 8567 that are unemployed and we divide by the labor force, and we get, what do we get? I guess I need to do it. 8567 divided by 245,332. We get 3.49%. Alright? Number 2. In July of 2008 in the state of Michigan, we have all kinds of problems. Let's see, we've got employed numbers of 4,987,000. That's full-time jobs. We have 60,000 in part-time jobs. Well, guess what? The 60,234 in part-time jobs, they are considered fully employed as well. And then we have 428,000 seeking employment. So we're going to call them the unemployed. And 300,000 discouraged workers, we don't include them. So our labor force is going to be these three numbers added together. So 4,987 plus 60,234 plus 428. Hang on, I messed up. Plus 428. I may have pushed the wrong button, but I'm pretty sure this is right. If it's not, we're still going to use that number. So then, to get our unemployment rate, we take the 428,000 people that are unemployed, and we divide that by, we divide that by the number of people in the labor force, and then multiply that by 100. Okay. Luckily, when we do a test, we're not going to have crazy numbers like this that are easy to punch the incorrect numbers. Alright, times 100. I got 7.82%. Alright. Number 3. In July 2008, in the state of Texas, there are 10,644 100 people employed. So we've got this many employed. And we got this many unemployed. They are added up to get the labor force. So I'm doing this in my head this time. Hope I did that right. So to get the unemployment rate, you divide the unemployed number by the labor force number multiplied by 100, and we get I got 4.61%. So that's how you do it. Now, according to number 4, it says 44,000 people become discouraged. So that means we actually have to make some changes in our numbers. We're going to subtract 44,700 from our number of people that are unemployed, because discouraged workers are no longer considered unemployed. Minus 44,700. So our new number unemployed is 469,971, and we have to divide that by our new labor force. So we also have to decrease the labor force by that number of discouraged workers. Okay, so 11,158,771 minus 44,700 is 11,114,071. So we multiply that by 100. Let's see what we get. 469,971 divided by 11,114,071, 4.23%. So notice what happened. When we got discouraged workers, our unemployment rate went down. So it's kind of an interesting phenomenon. Alright, real unemployment. This is just the rate of cyclical unemployment. So typically we'll use some number between 4 and 6% as our natural rate of unemployment. So if we go ahead and use 6, okay, the real unemployment rate when the unemployment rate is 7% would just be 7 minus 6 to give us 1%. So we would say that at any given time we always have frictional and structural unemployment. It could add up to as much as 6%. So anything above 6% we're going to say is cyclical or real unemployment. So that's why I got 1% for number 1. Alright, if the unemployment rate is 8%, what is the rate of frictional combined with structural, and what is the cyclical rate? Well, it's what I just described. Okay, 6% is going to be our frictional and structural. Okay, but that means the remaining 2% of the 8% total is going to be cyclical. Okay. If, however, we used 5% as the natural rate, then 5% would be the answer for frictional and structural, and then this would be 3%. Or if we used 4% as our natural rate, then 4% here and 4% here. So you'd have to be told what the natural rate is. If you're not told, just use 6%. That's a pretty decent amount. All right, number 3. If our unemployment rate is 5.5%, is it possible that we're in a recession? Well, it is possible, because remember the natural rate could be as low as 4%, in which case the cyclical rate would be 1.5%, and so we could have a recession. So it's hard to actually tell if we're in a recession based on the unemployment rate. You really have to look at the real GDP growth number, and so unemployment is not the perfect measure for that. Alright, let's look at unanticipated inflation. So let's pretend for a second that you borrow $1,000 from Best Buy for 1 year at 5% interest to buy an awesome TV. Although you didn't anticipate any inflation, there is unexpected inflation of 5% over the life of the loan. So what's the real interest rate on your loan? Let me see if I have a formula for that. Oh, good, I do, right here, number 11. So the real interest rate is equal to the nominal interest rate minus the inflation rate. So it says here 5% is the nominal interest rate, and all of a sudden we do have 5% inflation, so we subtract that. What's the real rate of interest? 0%. So the next question is, who gained from the inflation? Well, if I'm borrowing money for the TV and I am really only paying a 0% interest rate, then I am definitely gaining. Okay? So the borrower gains in this situation because they get to pay back money that is worth less than when they borrowed it. Okay? Who lost as a result? Well, it's going to be Best Buy in this case, because Best Buy is loaning money where they thought they were going to earn 5%, but they're really only earning 0%. And so they're losing money because the money they get paid back with isn't worth what it was when they loaned it. Alright? So that's why inflation can affect borrowers and savers and creditors all differently. Okay? So we have several more examples where we look at real interest or real income changes to determine if people gain or lose from inflation. So when banks lend out billions of dollars in fixed-rate home mortgages to consumers, unexpected inflation will cause, well, the bank is going to be sad and the borrower is going to be happy. Alright, and that's because the real interest rate is going to decrease. So borrowers like it when the real rate decreases, but banks don't. Okay? By the way, here's your rule of thumb. If you have to, just memorize this. So with inflation, creditors and savers lose. Okay, because the money they're paid back with is less than when they loaned it or when they saved it. Alright, but debtors, the debtors always win with inflation. Okay? Here's another example. This is a little bit different. It's not a debtor or a creditor or anything like that, so you have to kind of think it through. You sign a 3-year lease at an apartment complex for $900 per month for the length of the lease. Unexpected inflation is going to cause you to actually be happy. Landlord will be sad. So let's explain why. During the 3-year lease, you're employed and you're getting raises. And if there's more inflation, your raise gets even bigger. But your apartment rent remains $900. So you're gaining by this because your income rises, but your rent stays the same. Okay? The reason the landlord loses is because all of his expenses are going up with inflation, but his income, your rent, is not changing, and so that's why he loses. All right, number 3, you loan $10,000 to your cousin at 7% so that she can start a small business. If inflation jumps from 2 to 4% per year, then, so let's look at this one. The nominal rate is 7%. They expect inflation to be 2%, which means the real interest rate is expected to be 5%. So the two parties go into the loan agreement expecting a real interest rate of 5%. When inflation came in at 4%, now the real rate of interest is only 3%. So the borrower is only paying 3 instead of 5. The loaner, the lender, is earning 3% instead of 5. So you as the lender are going to be sad. Your cousin, the borrower, is going to be happy. All right, number 5. Federal government owes $20 trillion. Unexpected inflation will actually cause the government to be happy, creditors to be sad. So if you loan somebody money and all of a sudden inflation eats away at what they're paying you back, yeah, you're going to be kind of bummed about that. And actually, believe it or not, this is a little bit cynical, but governments do anticipate that inflation will help them grow themselves out of debt. And so that's why a lot of people just don't worry too much about that $20 trillion, although it is a very big deal. All right, number 5. I buy a house at 5.5% interest in 2003 when inflation was 1% per year. Now inflation is around 4% per year. So in that situation, I am going to be pretty happy because initially I thought I was going to be paying 4.5% real interest rates, but because inflation came in at 4 instead of 1, I'm only paying 1.5% real interest rate. So Wells Fargo, the mortgage company, would be sad about that. Anyway, I hope that helped. That was a lot of stuff that we just went through. Now, one of the things you're going to have in front of your face is this formula sheet, so that will help you, but you have to know how to use it. Okay, if you don't know how to use it, then it can be difficult. So practice doing those problems and study, and you should be okay.